Somewhere above you right now, light is falling. It left its source before your grandparents were born, before their grandparents were born. It crossed billions of kilometers of empty space, entered our atmosphere, and landed on Earth tonight, on you, on everyone looking up at the same sky. And the star that sent it may already be gone. That is not a metaphor, that is physics. The stars you see on any given night are not a live picture of the universe, they are a delayed one. Some of those delays are decades long, some are centuries old. Some are so long that the object you're looking at ceased to exist before humans learned to write. You are not seeing the universe as it is, you are seeing it as it was. And the further out you look, the deeper into the past you go. This is a direct consequence of a single number. A number that sounds tidy and manageable on paper until you follow it all the way to its conclusion. That number is called a light year, and once you understand what it actually means, not the definition, but the reality underneath it, the sky stops feeling like a view. It starts to feel like a one-way window into something that's already gone. Light travels at 300,000 kilometers per second, not per hour, per second. In the time it takes you to blink, light has already circled the Earth more than 7 times. In the time it takes you to say the word fast, it has crossed a distance longer than the gap between the Earth and the Moon and returned. Now take that speed and run it for an entire year. Every second of every hour of every day for 365 days, traveling at 300,000 kilometers per second without slowing, without stopping, through nothing. You get 9.46 trillion kilometers. That is 1 light year. We use the term because the alternative, writing out 9,460 billion kilometers, doesn't actually help anyone think. So we compress it. We call it a year of light. We make it sound manageable. And that's the first place this quietly breaks down. A light year isn't a human unit that happens to be large. It's a number so far outside the scale of anything we've ever physically interacted with that the label we give it is essentially cosmetic. It makes the distance easy to say. It does not make it easy to cross, or survive, or even meaningfully imagine. To give you a sense of the gap, the fastest a human being has ever traveled is roughly 40,000 kilometers per hour, aboard the Apollo 10 capsule on its return from the Moon. That felt extraordinary. That was a genuine achievement of human engineering. At that speed, reaching the nearest star would take about 114,000 years. We have not gotten meaningfully faster since. The speed record for an uncrewed probe is higher, but not by an order of magnitude that changes anything at cosmic scales. We are, in practical terms, nearly stationary relative to the distances a light year describes. The nearest star, Proxima Centauri, is 4.24 light years away. That's roughly 40 trillion kilometers. Our fastest probe would take over 70,000 years to reach it. Think about what that means in human terms. Every civilization that has ever existed, every empire that rose and fell, every generation that lived and died since the beginning of recorded history, all of that fits inside a fraction of the time it would take our best machine to reach the closest star to our own. And that star is, by cosmic standards, essentially next door. So you might think, we just need faster probes, better technology. That's a solvable problem. But the speed of the probe was never the real problem. And what actually limits us is something that doesn't yield to engineering. Because the faster you go, the more the universe changes the rules on you. Here is how the scale actually works. Not to impress, but because each step collapses something you thought might help. The Moon is 1.3 light seconds away, close enough that the Apollo astronauts experienced a real, noticeable delay when speaking to mission control. A pause, even at the speed of light, across a distance we consider our backyard. The Sun is 8 light minutes away. If it disappeared right now, completely and instantly, you would not know for over 8 minutes. The sky would stay blue, the warmth would stay on your skin. The information simply hasn't arrived yet. you would be living inside a reality that had already ended. Pluto sits about 5.5 light hours out. The New Horizons probe, one of the fastest machines humanity has ever built, took 9 years to reach it. 9 years to travel what light covers between breakfast and dinner. And Pluto is still inside our solar system. Step outside it, and you reach Proxima Centauri at 4.24 light years. If the ancient Egyptians had launched a spacecraft the moment they finished building the Great Pyramid, traveling at the speed of our fastest modern probe, it still would not be halfway there today. That is a single step on the cosmic distance ladder. Most of the stars visible to the naked eye from Earth sit between 10 and a few hundred light years away. Polaris, the North Star, is about 430 light years out. The light you see from it tonight left during the early 1600s, when Galileo was still alive. Betelgeuse, the red giant on Orion's shoulder that may be close to exploding, is roughly 700 light years away. If it went supernova tomorrow, we would not see it for 700 years. We would have no warning, no countdown. It would simply appear one night, bright enough to cast shadows, and we would know we were seeing something that happened 7 centuries before we were born. You might think, so we build faster ships, push toward a fraction of light speed. Fusion drives or light sails could theoretically get us to 10 or 20% of the speed of light, cutting a 70,000 year journey down to 20 or 40 years. Progress, a human lifetime. Except that solution creates a problem that no amount of engineering removes. At those velocities, time itself behaves differently for the people on board. They age more slowly relative to everyone left behind. You could send a crew. They might survive the journey, but they would arrive at Proxima Centauri 40 years later to find that everyone they knew on Earth had been dead for decades, and the civilization that launched them had moved on, or changed, or forgotten the mission entirely. A faster ship does not solve the problem. It trades one version of it for another. There is also the question of what you return to, if you return at all. A crew traveling at 20% of light speed would experience time dilation significant enough that the world they left no longer exists in any meaningful sense when they get back. The people, the institutions, the context that gave the mission its purpose, all of it is gone. You cannot solve the isolation of deep space by going faster. You just relocate it. And that is still just the nearest star. We have not even left the local neighborhood. The Milky Way is roughly 100,000 light years across. To cross it at the speed of light, the absolute physical speed limit of the universe and a speed no object with mass can actually reach, would take 100,000 years. More time than our species has existed on Earth. We sit about 26,000 light years from the galactic center, tucked into a quieter outer arm. That distance alone, from here to the center of our own home galaxy, is something no credible physics allows us to cross within a human lifetime under any technology currently theorized. The Milky Way contains between 200 and 400 billion stars, potentially trillions of planets, and the voids between those star systems are measured in light years, not light minutes, not light hours, years of empty space between each one. It helps to sit with what that emptiness actually means. If you shrank the Milky Way down to the size of the continental United States, our entire solar system would be smaller than a grain of sand. The distance between that grain of sand and its nearest neighbor grain would still be several kilometers. The galaxy is not a dense field of stars the way it appears in illustrations. It is mostly nothing. Vast, cold, lightless nothing, interrupted occasionally by a point of heat so distant from the next one that the gap between them is measured in years of travel at the fastest speed the universe permits. You might think, fine, we cannot travel there, but we can see it. We can observe, learn, understand, even if we cannot go. Here is the problem with that. When we look at the far side of the Milky Way, we are seeing it as it was 100,000 years ago. The light arriving tonight left those stars before modern humans had migrated across the Earth. some of those stars no longer exist in the form we are observing. Some have already exploded. We have no way to know because that information is still in transit and will not arrive for thousands more years. Observation is not a substitute for presence. It is a delayed record of a past we cannot verify. Consider what that means for any attempt to understand our galaxy as a living, current system. Every map we build of the Milky Way is a composite of different pasts. Stars near us are shown as they were a few hundred years ago. Stars on the far side are shown as they were 100,000 years ago. We are not mapping a galaxy. We are assembling a mosaic of different moments in time and calling it a picture. The Milky Way as it actually exists right now is something we have never seen and cannot see. Seeing across the galaxy does not tell us what is there. It tells us what was there. And past our galaxy, the delay grows so severe that the word seeing begins to mean something else entirely. The nearest large galaxy, Andromeda, is 2.5 million light years away. On a clear dark night, far from city lights, you can just barely see it with your naked eye. A faint smudge of pale light. What you are actually looking at is light that left Andromeda 2.5 million years ago, before our species existed. Our earliest hominid ancestors were just beginning to walk upright when that light started its journey here. A trillion stars, an entire galaxy, and what we see is a ghost. Beyond Andromeda, galaxies cluster into groups, and those groups stretch into superclusters spanning hundreds of millions of light years. The Virgo cluster alone contains between 1,300 and 2,000 individual galaxies, each with billions of stars sitting 50 to 70 million light years away. The observable universe stretches roughly 93 billion light years in every direction. There is a number that astronomers use to describe the total number of galaxies in the observable universe. Roughly 2 trillion. 2 trillion galaxies, each containing hundreds of billions of stars, spread across 93 billion light years of space. And yet, despite that almost incomprehensible abundance, the distances between those galaxies are so vast that the universe is, by volume, almost entirely empty. Matter of any kind, stars, planets, gas, dust, occupies a fraction of the total space. The universe is not full of things, it is full of distance. You might think, then we simply need more time. Given enough of it, light from those distant regions will eventually reach us, and we will see further. But that is where the expansion of space closes the door permanently. The universe is expanding, and it is accelerating. Galaxies beyond a certain distance are being carried away from us faster than light can travel between us and them. Not because they are physically moving through space at those speeds, but because the space between us is stretching, adding distance faster than light can cross it. There is a boundary called the cosmic horizon, past which no signal, no light, no information of any kind will ever reach us. Not given more time, not with better instruments. What lies beyond that horizon is real. It may contain stars, galaxies, entire civilizations. We will never know, not because we lack the technology to look, because the geometry of the universe itself prevents it. And here is the part that tends to be glossed over. This boundary is not static. Because the expansion is accelerating, the cosmic horizon is effectively moving closer to us over time. Galaxies that are technically observable today, galaxies whose light is still just barely reaching us, will one day cross that threshold. Their light will redshift beyond detection. They will simply vanish from our sky, not because they moved, but because space stretched the gap beyond what light can ever bridge. Future civilizations, if any exist, will inherit a smaller observable universe than the one we have now. The observable universe is not everything that exists. It is everything we are physically permitted to see, and the gap between those two things is not shrinking. It is growing. Here is what the light year is telling us once you follow it all the way through. It is not just a unit of distance. It is a unit of delay. And that delay has consequences that do not resolve with better technology, more time, or any plausible development in physics. Every observation we make is already outdated by the time it reaches us. The star you see tonight may have exploded a century ago. We will not know for another 100 years. The galaxies we study at the edge of the observable universe, we are seeing them as they were over 13 billion years ago, near the beginning of everything. Whatever they are now is permanently beyond our reach. There is something quietly disorientating about this that goes beyond the scale of the numbers. Science is built on the idea that observation tells us about reality, but at cosmic distances, observation and reality are decoupled by time. What we call the universe is not the universe as it is. It is a collection of signals from different depths of the past, arriving at different moments, from objects that may no longer exist in any recognizable form. We are not observers of the cosmos, we are receivers of its history, and that history gets older and less complete the further out we look. You might think, at least we can communicate across those distances, send signals, make contact. A radio wave travels at the speed of light, so the delay is the minimum possible. Send a signal to Proxima Centauri today and it arrives in just over 4 years. A reply arrives 8.5 years after the first transmission. One question, one answer, nearly a decade. For a star 100 light years away, a single exchange takes 200 years, longer than the United States has existed as a country. To anything at intergalactic distances, a two-way conversation would take millions of years to complete. Even if intelligent life exists out there, and statistically it is not impossible, meaningful communication is not merely delayed. It is functionally impossible across the timescales of any civilization. This is sometimes called the Fermi paradox, the question of why, given the size and age of the universe, we have not detected any sign of other intelligent life. One answer, and not a comforting one, is that the light year itself is the explanation. Civilizations may exist, signals may have been sent, but the distances are so vast that the signals either haven't arrived yet, or arrived before anyone was here to receive them, or will arrive long after we are gone. The universe is not silent because it is empty. It may be silent because the distances between minds are simply too large for any signal to matter. The light year, followed far enough, describes a universe built around separation. Not by accident, not temporarily, but as a fixed consequence of how space, time, and the speed of light interact at scale. The distances are so vast and the speed limit so absolute that every region of the universe is, for all practical purposes, permanently unreachable from every other. A light year is a clean, practical unit, a way to say enormous distances in 2 syllables instead of 13 zeros. But the reason it exists, the reason we needed it at all, is because the universe built distances that our other units simply could not hold. Distances that absorb entire human lifetimes without producing a single round trip. Distances that turn observation into archaeology and communication into letters written for people not yet born. The light reaching you arrived from a star 1,000 light years away left during the Middle Ages. It has been traveling ever since. The star itself may be gone. The confirmation of that fact is still somewhere in space, still moving toward us, and it will not arrive for centuries. This is not a temporary problem. It is not a frontier that better telescopes or faster engines will eventually push back. The expansion of the universe is accelerating. The cosmic horizon, the outer boundary of everything we can ever observe, is contracting in real terms. Regions that are technically within our view today will eventually drift beyond it forever. The universe we can see is not growing, it is closing. A light year measures distance, but following its conclusion, what it actually measures is the size of the permanent gap between what exists and what we can ever reach, or see, or know. That gap has a name. We just spent this entire video learning how to count it, and it will never get smaller.